We graphed through some sines and cosine stuff before. And usually what I like to do is I like to start by graphing sine via quadrantals. So if I graph sine via the quadrantals, well, first of all, what I need to do is plot my ordered pairs for the quadrantals. And if I'm not mistaken, we can do this correctly. When you plot your quadrantals, what is the ordered pair on the right-hand quadrantal? 1 and 0. Okay. Vertical, 0, 1. Left, -1 and 0. And vertical down. Okay. So as you go around the circle, as you start with your value, I'm going to start with sine. Sine starts at what value at 0? Sine, 0. As I get to pi over 2, sine becomes 1. As I get to 180, sine is back to. As I get to 270, I'm at. And then I come back up to 2 pi, and I'm at 0. So as you go around the sine value, sine increases, decreases, and increases again as it goes through. So if you plot this horizontally versus in a round, if you will. Bless you. When you start looking at these things like this, my vertical and I start at 0. What is the maximum height for sine? 1. What's the minimum? -1. Does it ever go beyond that? No. Now, it starts at 0. Where does it end? At one full revolution starts at 0 and it ends at? But we call it 2 pi. Thank you. You're not wrong by saying 0, because as you start at 0, you go all the way around, you wind up back at 2 pi. So what happens here is, you think about it, sine repeats itself after one revolution, and then it goes on again, and again, and so on and so on. So sine, and as we get to it here in a second, cosine, are what we're going to call periodic functions. They replicate themselves after a specific period, then they just start over again. They are continuous. There is no breaks to sines or cosine graphs, because there's no values at which that they are undefined, whereas tangent has undefined value. Halfway between 0 and 2 pi is what? Pi, good. What's halfway between 0 and pi? Pi over 2. And again, what's halfway between pi and 2 pi? 3 pi over 2. Notice what we just plotted. We plotted the quadrantals. We broke it into sections, where it starts, where it ends. Cut it. Where it starts, where it ends. Cut it in half, and we cut those two sections in half. You put it into quarters, if you will. Okay. So we're looking at y equals sine of x. We're turning this into a equation. Sine starts when sine is 0. What's the value of it for the y? If x is 0, the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is, and then back at sine of 2 pi is 0. And it just goes and does, its thing. Okay. It does its oscillation, if you will. Now, if you're in physics, you've seen this if you've done sound waves yet. Have you done sound? Sound waves have what's called an amplitude and a period. Okay. The amplitude is the height at which it goes, distance from 0. Okay. The period is how long it takes for it to replicate one full oscillation. Exact same thing. Okay. Now, if I look at a cosine graph, if I look at cosine, now, when cosine, what is the cosine of 0? It's 1. The cosine of 0 is 1. The cosine at pi over 2 is 0. The cosine at pi is -1. Cosine at 3 pi over 2 is back to 0. And once again, cosine at 2 pi is 1. So the cosine graph, a graph of cosine, if you look at it, is the exact same thing as sine shifted 90 degrees. Yes, ma'am?
So it only goes that way, right? Like it only goes to the right.
Good question. It does go to the left as well. We usually, when we start these things, we start it at 0, and then we continue on. You can move backwards and forwards, and we will get to those shifted things by adding and subtracting specific values to it. But it all starts with what we're going to call a parent function. Okay. So it doesn't mean it does go to the left, because you can go the other, remember, negative angle goes the other direction. So if you think about it, if I'm at negative pi over 2, what is the sine value at negative pi over 2? It's -1, so it's back down here. So it would just continue. It would still do the exact same thing. It just keeps going and going. Does that make sense?
Yeah.
Great question. Okay. So what's going to happen here with sines and cosines is that they kind of follow the exact same rule. It just means that a cosine value starts somewhere differently than a sine value, because when you start cosine, you start at 1. When you start at sine, you start at 0. Okay? So we have this generic questions on that so far. Remember, what we're doing is we're taking this directly from the unit circle, and basically we're looking at quadrantals. Okay? This is where the quadrantals come really back into play. All right? Excuse me. So when we look at this, we get this bit of information. We're going to use this as what's called parent functions for today. Okay? We have these things called parent functions. Y equals a sine bx, and y equals a cosine b of x. And these values of a's and b's mean something. These values of a's and b's will have specific meanings to them. A is really easy. A is going to stand for what's called the amplitude. Okay. A stands for what's called the amplitude. It's like you were saying earlier with sound waves. The amplitude is how high up or how low something goes for when you're talking about a sound wave. It's a multiplier. It's how frequencies work. The higher the number of the amplitude, the higher the pitch. The shorter the period, it's not louder of it, but it's how it's more of a higher frequency versus a low frequency is a longer period. So you have a high, the wave, the tighter the wavelength, the higher the frequency. The longer the wavelength, the lower the frequency. Yes. And then this is pitch. Is that right? Is it volume or pitch? Oh no, you're right, because this would be pitch, because that's pitch. Is this volume then? I took physics. And I'll ride the wave where it takes me. So basically you get this stuff. This value of A is going to tell you the direction of the graph. If A is positive for sine, you go up first. If A is negative, you go down first. That's the idea of saying which direction.
Yeah, that makes sense.
Okay. So A stands for amplitude. It tells direction. The absolute value of A is how high up it goes on the y-axis. It tells you your, what we're going to call a maximum and a minimum value, how high up or how low it goes on the x-axis. The b value helps you to distinguish what the period is going to be. Okay? Now, sine and cosine take 2 pi to oscillate all the way around the circle. So if you're starting at 0, you go all the way around, it takes you 2 pi to get to where you started. By putting some sort of a multiplier to it, you can either get, the period can get longer, or the period can get shorter, depending upon what we call this b value. So this b value helps define the period. It helps define the period. So for sines and cosines, the period will always be 2 pi over the absolute value of b. It is very rare in algebra 2 that we'll have b values that are negative. Okay? Don't get me wrong, I do not believe we see it very often, if at all. I know you see that in pre-calc because there are negative angle formulas and stuff that they'll get into this a little bit here and there. Now, again, this looks like it's going to be a lot of craziness, but when you start breaking it down, once you're able to define that period, just like we did with the originals, it's really fast. Okay? And it's not going to be so crazy. Oops. Yeah, we'll be the gang sign, the math gang sign. Who? Who? Goonies. Oh, it's Sloth! Rocky Road. Hey, you guys! What? You've all seen Goonies, right? What? You've never seen the Goonies? Are you kidding me? The Truffle Shuffle? Oh,
We should watch it. That's a shame.
I recommend the Goonies. It's great.
You recommend a lot.
What's his name? Mikey, the little Mikey guy. He was Rudy. Wasn't he like in the Lord of the Rings or something? One of those movies. Anyway, it's good. Steven Spielberg, right? Spielberg movie. Yes, he has.
She's making a list.
Oh yeah. No.
It's okay. I remember most of them.
Oh, I had a student from 12th hour came up to me the end of last week. He said, "Oh, Smurfy, I forgot to tell you. My dad said that he had a copy of the movie Rad on Rad on VHS, and he wore it out because he watched it so much." I'm like,
Oh my god.
I forgot. So let's do this. Let's do y equals 2 sine of 4x. We're going to graph this. And what I like to do here whenever I'm graphing sines, cosines, tangents, and when we get to shifted ones also, just like because HOK comes back, just like we did before whenever we had parents and shifted functions, the more info we write out first, the easier it'll become later. Okay? So if I'm looking at y equals 2 sine of 4x, I have to think about it as, okay, what's my value of A? What's my value of B? Okay, so right away, I'm going to write that down. I know that my A value is 2, my B value is 4. That means my amplitude is what? 2. The period is going to be defined by 2 pi divided by 4. Okay? So what does 2 pi divided by 4 equal? Good. So that means my period is at pi over 2. I'll worry about intercepts, max, and minimums in a second. So now what I do is I plot my little sideways t-chart. I know I'm going to start, sine value always starts at 0. Whether the amplitude is positive or negative, a parent function of sine will always start at 0. Because the sine of 0 is 0, no matter what. And then the amplitude times 0 will always be 0. So 4 times 0 is 0, sine of 0 is 0, 2 times 0 is 0. Hence, 2 sine 4 of 0 is 0. Convenient how that works. Okay. Now, my amplitude tells me that that's how high up it's going to go. And the opposite of my A value would be how low it will go. So I know that my amplitude is no longer 1, it is 2. I know that sine starts at 0 and it ends at its period. So what do I put out there for its period endpoint? Pi over 2. So what we do is we plot this out here at pi over 2. What's half of pi over 2? Pi over 4, good. What's half of a fourth? An eighth. Now watch what happens. You have 1/8, 2/8, 3/8, because this is 4/8. It's super easy to work with your fractions, no matter what they are. If it was a 16th, you'd have 1/16, 2/16, 3/16, 4/16. By breaking it into these quarters, each one of them is going to be one portion of it. Now, you don't have to worry about scaling this at all. Your breakpoints label is what you need to do. Does that make sense? Okay. Now, sine. Sine values, a sine graph, a sine of x, always starts at A, always starts at 0. It goes to A, back to 0, opposite of A, and then to 0. That will never change for a parent function. Okay? It will never change. So at 0, so my first one is 0. My next one is at A, so it's at 2. It goes back to 0. It goes to the opposite of A, and it goes back to 0. And those are your points. Yes, ma'am. Now, one of the things I will start to get at is, as we get to the shifted stuff, I'm going to ask that you will list your ordered pairs. I think today might be okay just to get the hang of how these things look by not having to do that little bit extra work, just to kind of get the practice of plotting out your breakpoints. Will be okay. But as we get into this, we will start to list our ordered pairs because I have a little trick when we do shifts. On what? Yes. Making life easier one trig function at a time. My kids love that movie. It is really dumb, but it is kind of funny. I mean, it's like bad good, but remember, hold on. Remember, for 9-year-olds and 6-year-olds. Emoji. I wouldn't recommend it. Anyway, intercepts. Intercepts, you're intercepting, in this case, where are you crossing your x-axis? You cross your x-axis at 0, pi over 4, and pi over 2. The reason why I was trying to show you guys that is because think about it in terms of quadrantals. You end a sine on a quadrantal, you start a sine on a quadrantal, where it's equal to 0. And then it crosses halfway through as well, where it's 0. Now, maximum. Where does it reach its maximum point? It reaches it at pi over 8, comma 2. The max is at pi over 8 and 2. Remember, this is your x, this is your y. We're talking about two-dimensional stuff. And then your minimum would be at 3 pi over 8 and negative 2. It's not crazy, is it? It's the idea, even still, even when we start throwing in negatives and shifted stuff, it's the exact same process over and over and over again. It's the idea that you start it for sign. You start at 0, you ended your period, half, and add it. It goes the same way every time. Yes. No, and I think it is. Again, there's a lot of there's some subtlety. It's not like having to use the trig identities, and there's nothing like that built in any of that stuff. But it's just some shift stuff. You just gotta watch your signs, SIGNs. That's usually what happens. Let's try one with cosine, but we'll do this one. So we have to do A. We'll make this negative. Sorry, the cursor stuck into it. So we have y equals negative 1/3 cosine pi x. Now, cosine graphs, when you go back to the original cosine graph, the cosine graph started at 1, it went to 0, negative 1, 0, and then back to 1. So it starts at its, so basically cosine starts at its A value, it goes to 0, opposite of A, 0, back to A. Okay, cosine graphs will always start. A basic one is A, 0, opposite of A, 0, and A. Because remember when you have y equals cosine x, your A value was 1, so it started at 1, 0, negative 1, 0, and 1. Now in this case, what's my A value? Negative 1/3. So my A value is negative 1/3, which makes my amplitude what? 1/3. Good, you remember about the absolute value. Okay. What's my value of B? It's pi. My value of B, you're getting ahead of me. My value of B is pi, which means my period will equal 2 pi over pi, which is 2. All right. Is it okay to have a period that's just a 2, not with a pi in it? Absolutely. Amplitude is always absolute value. So when you go here, again, I start at 0. What do I end at? 2. Okay. What's half of 2? 1. What's half of 1? And what's between 1 and 1/2? Between 1 and 2 is 3/2. Excuse me. All right. My A value is negative 1/3, so I have a positive 1/3 and a negative 1/3 I have to mark off. Now, my A value is negative 1/3, which means I start my cosine graph at negative 1/3. So what that means is that you just invert it. You still go through the same idea. You start at negative 1/3, you go to 0, the opposite of A, 0, and back to A. In this case, your maximum would be located at 1, 1/3. Your minimum would have been at 0 and negative 1/3. What are you doing? We're doing sines and cosine graphs. Yeah. No.
So you're never gonna have this in the real world?
What do you mean? You're never gonna have to look at circles?
No.
I mean, that's just the graph of a point on a rolling circle.
In a roundabout way.
Ah, he's right there.
That's like starting at the bottom of the circle. You know, watching it go around.
It's just going the other direction. It's like moonwalking.
Quick, get a circle.
How's moonwalking? Wow, his shoulders.
Hey, on that
I
note.
really.
Don't quit your day job.
You.
Wait, so for the mid, do we put 0 or -1/3 or 2 -1/3?
Either one is fine, honestly. Technically, if you remember how we did intervals, we always started we included 0, we did not include 2 pi. Okay, so I would say it should technically be that one, but it's quick. All right. It's not so bad, is it? So my max would be just so what I would do would be at 1 comma 1/3. The min, just like Ken was asking, when you think about how we did intervals as for solving solutions, remember how we always included 0, but we did not include 2 pi? So I would always put my minimum value, the first minimum I would see going from left to right, just because that's just technically the right way of doing it. So it would be at 0 and -1/3. Okay. Your intercepts would have been at 1/2 and 0, 3/2 and 0. You won't have to find intercepts as often as you think. Yes, ma'am. They don't show up as often. That's why I didn't throw it on this one. Max mins usually are asked a lot more than these are. Okay, let's try this one. Take a second. Do this one. That's generally as goofy as most of these things get. So let's see, we get a value of -4, b value of 3/4. Your amplitude therefore becomes 4. Your period will be 2 pi divided by 3/4, which is 2 pi times 4/3. So it's 8 pi over 3. Okay. Now, a quick reminder on fractions, and this is what most people start going. When you're, that's good. That's like an impression of your sister. It's a joke, because she's such a troublemaker. So when you start. We start going through this. We know our period's at 8 pi. 8 pi over 3. And I start at 0. Now, when you think about it, when you take half of something, aren't you just multiplying by 1/2? So 8 over 3 times 1/2 is 8 over 6, otherwise known as 4/3. What's half of 4/3? 2/3. So this is real tough now. See if you can find the pattern. 2/3, 4/3, something thirds, 8/3. You're so close. I know. So 6/3 would be 2 pi. Yeah, that's fine. And Sarah, it's a good thing. When we start to do shifts, it won't be a bad idea if you keep things in the same denominator, because we'll have to add and subtract things together later on. And it's not a bad thing. And I wouldn't mark any of that wrong, because when we get some of the shifts, we might have a period that has 8 pi over 3, but you might have to move it pi over 2. So you'd have to add 1/2 or pi over 2 to 8 pi over 3. You'll have all these common denominators and stuff. That's why I always, when I go to do my shifting, I will list out ordered pairs, because it's easier to add stuff on paper, like in a sequence, versus try to do it in your head. Sine value. This was a sine graph, right? Sine starts where? 0. It goes to what? What was your A value? Okay. 4 and -4. So it starts at 0, -4, then where? Then where? -A, and then back to. Oh, that was badly drawn. Sorry. That's whatever. It's close enough. I have one last example for you, and then I will give you a handful of these to try. Hey, convenient, they've all finished at the same time. Suspicion abound. Oh. Yeah. When they finish and just start taunting you, they go, that was an old Daryl Strawberry chant they used to do. Daryl. Whatever. Anyway, write a sine equation with an amplitude of 10 and a period of 4. Okay. Yep. Now, what this means is you have to figure out an equation, y equals a sine b of x. Now, the amplitude being 10, that means that your a value is could be 10 or -10. It could be either, but I would just write 10. So I would say, how about we'll write a positive sine equation. So we know that right off the bat that it's going to be y equals 10 sine. Well, if my period is 4, that means 4 has to equal 2 pi divided by e. And then when you have fraction equal fraction, what do you do along the diagonals? Yeah, just exchange O, change O. So b will equal 2 pi over 4, which is pi over 2. You guys walking and going, what happened? It's not bad. In all, if you come in Flex, I'll show you how to do it. If not, we do shifting of this stuff tomorrow. You'll probably pick up on it real quick. Okay.
Horrible.
Terrible?
Impossible. Can't do it.
What I have on here, I kind of try to put it all to fit. This is section 14.1. It's on page 836. I will post this through, but I left it all on one thing if you want to just take a picture of it. What I have here is I want you guys to do the, 26 through 48, and it's all graphing, and you're drawing one cycle of it, which means just one period. And don't do anything that says tangent. So if it says, like for example, on 42, it says tangent. Don't do it. 40, it says tangent. Skip that. All right. So that's what we're looking at. And try those out. Okay. What's that? Yeah, I just thought if you wanted to grab a picture real quick, it would be there too. So, yeah, quick, send me an email though. Where you going? Cool. We are going to probably do this shift tomorrow and maybe a little bit more of it on Friday. And you did fine with this. Really, all you're doing with shifted ones is you plot everything. So you have an H value movement left or right, and then a K value movement up or down. So you'll plot the parent function first, and then we'll I want you to see how we list out the ordered pairs. So what I would do is list out all 5 of my ordered pairs, and then the next part I would write up each value means I'm moving it left or right. So I take my x and x plus pi over 2. K value I'd say y minus 4. So for all my ordered pairs I have listed, I would just add pi over 2 and so on, and then I would just replot. It's not that bad. It just they take a little bit of time to get through because there's a lot of
Very well.
Better look good.